Hi everyone, let's have a quick video about properties of vectors. Here are the list of the properties of vectors. Let's start with the first one. As you already know, vectors can be indicated as a line with direction. For example, this vector starts at point 0. We can label it as A or B or R, whatever that works for you. Or sometimes if we talk about force, it could be F. We put an arrow on the top, which means it's a vector. For example, in this vector, let's assume that it's 30 degrees above the horizontal, which means this vector, the magnitude is this large. The direction is at 30 degrees north of east side of the coordinating system. And then on the east side, we can go up and we can go down. But in this case, it's going up, which means it's 30 degrees north of east. I hope this makes sense to you. Let's give another example. Assume it's a 45 degrees north of west. How should we draw it? First of all, 10 Newton, and then 45 degrees north of west. First of all, west is on the left side of the coordinating system, so it should be on the left. Okay, and then west has north of west or south of west. In this case, we're looking for north of west, so we're looking for 45 degrees, which is in the middle. Okay, 45 degrees. And this should be the vector F that we are looking for. So here would be 10 Newton, that is the magnitude, and this is the direction. Again, we're talking about 45 degrees north of west. Okay, equality of two vectors. If we have two vectors, A and B, the condition for those two vectors be equal to each other has to meet two conditions. First of all, the magnitude. Secondly, the direction. So if both of them, they share the same magnitude and they are at the same direction, which means they are equal to each other. Second property, movement of a vector in a diagram. It means that a vector can be moved in parallel to itself without being affected of its value or the direction. So I was moving this vector, let's assume it's called A, from the top to here. And still it's the same vector because I just parallelly moved it to itself. And if I move it to here, still it's the same vector. Hey, it's still the same vector A. What if I move it to here in parallel to itself? Still, it's the same vector. And what if I move it down to here? Still, it's the same vector because the vector is just being moved in parallel to itself. The magnitude and the direction does not change. So they are equal to each other and it's the same vector. So we call it a movement of the vector without changing its value. Now, what if I now have another vector? Let's call it B. Is this B the same vector as A? No, it's not. Because seems like the magnitudes are similar or maybe equal with each other, but the direction apparently is different. So vector B is not equal to vector A. Okay, what about negative vectors? Two vectors are negative if and only if they met two conditions. Number one, the same magnitude. Secondly, the direction will need to 180 degrees apart. In other words, original vector plus its negative vector would be equal to 0. For example, if I have a vector A, now how should I draw the negative vector? Apparently, the magnitudes needs to be equal to each other. But the direction will need to be opposite. So it's 180 degrees on the other end. So this is called a negative A. When we add them together, because they are going to the opposite direction with the same magnitude, the total will be equal to 0. We'll talk more about resultant vector later. Okay, let's give another example. What if I have a vector right now, let's call it B, and what should be the negative vector? So again, you can start off the same point and go to the opposite direction and have the same magnitude, and you can name this as negative B. Or if you would like, you can draw like this. Okay, same magnitude, the same length. Okay, direction will be opposite. So this is also negative B, called the negative vector. Okay, let's do another example. Vector C, let's assume that it's going to this direction. Okay, and the negative vector, again, you have different ways to draw it. Remember the movement of the vectors. When you move the vector in parallel to itself, the value does not change. So right now I'm going to start off with the same point of vector C, and I go to opposite direction and the same length. This will be negative vector of C. Next, commutative law of addition. In this case, assume that we have vector A and vector B, and when we add them together, the order does not really matter. In other words, it will be equal to vector B plus vector A. Or if we have more, let's see, we have A plus B plus C and plus D. And then we can change the order randomly. B plus B plus A and plus C. So still they are equal to each other. So that's called the commutative law of addition. Next, vector subtraction. So vector subtraction, for example, if we have vector A minus vector B, it's called A subtract vector B. And in this case, we can actually convert it into addition. So it will be vector A plus negative vector B. Remember, we talked about negative vector earlier here. So this will be the negative vector of a B. And you all know how to draw the negative vector or find the value of the negative vector if the first one is known. So for example, if we have vector B here, then the negative vector B would be like this. When we add the two vectors together, it's called the resultant vector. And again, this is a little bit more complicated and we'll discuss about it in another time. Lastly, multiplying or dividing a vector by a scalar. Assuming that we have a vector A, like this, and now we are multiplying this vector by a scalar. A scalar is mainly just a number. So let's assume that it's 2 for this scalar, and we're looking for the new vector 2A. So in other words, we are multiplying a vector A by a scalar number 2. Okay, so the end result, first of all, it is still a vector, which means not only it has a magnitude, but also has a direction. And secondly, the magnitude will be multiplied or divided by a scalar. So in this case, it doubled. So in other words, the magnitudes will need to be doubled. Okay, now let's take a look at the direction. So if a scalar is positive, no change in direction. So in this case, the scalar is number 2 is a positive number, which means direction does not change. So still going to the same direction. This is a resultant vector for 2A. Now, what if we are looking for negative 1 over 2A? So in this case, if we see that the magnitude is divided by 2, so the length should be shortened by half. The scalar that we're using right now, negative 1/2, is a negative number, which means the direction will change to the opposite. So the direction will go left instead. And this will be the new vector after being divided by a scalar. Let's try another example. What if I have a vector B going up, and we are looking for a new vector? Let's assume that is 1/2 B. The result will still need to be a vector, which means not only have a magnitude, but also have a direction. And then magnitude in this case is divided by 2, which means it's shortened by half. So it'll be half of the size. The scalar right now is positive because it's positive 1/2. So the direction does not change. So still going up. This will be the final result we're looking for. What if we're looking for negative b, or let's assume that it's negative 2b. Okay, the result still need to be vector, but the magnitude will be doubled because it's twice of the size. Okay, now we need to figure out the direction. So -2, that is a scalar and it's negative. So the direction change to the opposite. So instead of going up, the new vector will going down. So this will be the new vector -2b. Okay, so this is about multiplying or dividing a vector by a scalar. I hope this is helpful. Let me know if you have a question. Have a nice day.